Okay, so picture this. You've got like a dedicated software engineer on your team, and their only job is to keep your data perfectly organized
Like a data janitor.
and updated.
Yeah.
Yeah, even when it's changing constantly.
Yeah.
That's what we're diving into today.
That's some serious efficiency.
Yeah. We're going to explore a technique from Snowflake's guide on connectors.
Oh,
It's
cool.
called Deferred Merge. And it's a clever way to handle those tricky tables, the ones that are constantly being updated without sacrificing
Wow,
performance.
always a challenge.
Right. Think stock prices, sensor readings, anything that changes, like faster than you can say database deadlock.
Makes sense. Yeah. It's like having a personal assistant for your data, making sure everything's filed correctly, even when like new information is flooding in nonstop.
Exactly. You've got a table packed with data that just won't sit still. Every time a new value comes in, traditional methods would have you rewriting huge chunks of data,
Oh, yeah.
even for a tiny change. Imagine rearranging a whole library just to update the due date on a single book.
Ugh. Talk about inefficient.
Right. And not just inefficient, but imagine the chaos.
Yeah, you'd be constantly stepping on your own toes.
Trying to keep everything in order.
Exactly.
What's fascinating about deferred merge is that it takes a completely different approach.
I like it already.
It recognizes that constantly rewriting everything is a recipe for disaster,
Yeah.
especially as your data scales.
Oh, sure. For sure.
So instead of this chaotic library analogy,
Right.
deferred merge introduces a much smoother system.
Oh, okay.
Can you break down the core idea for us?
Absolutely. Think of it as a three-part system: base table, delta table, and view. It's all about strategic separation. Your base table is like the main library, a stable, organized snapshot of your data.
Okay.
But instead of frantically trying to squeeze in every new update, you have this separate area called the delta table where all those incoming changes kind of hang out. It's like having a designated new arrivals section where things can be processed and sorted before they're integrated into the main collection.
Okay, so we've got our stable foundation. Right.
And a dedicated space for all the incoming updates.
Yeah, okay.
But how do we actually make sense of this constantly changing information?
Right.
How do we access the most up-to-date version of the data?
That's where the view comes in. It acts as a dynamic lens, seamlessly combining the base table and delta table, so you always see the most current state of your data without any of the messy behind-the-scenes shuffling. It's like having a librarian who instantly knows where every book is, even though it's still being processed in the new arrivals section.
So instead of constantly rewriting the whole database
Right.
or rearranging the entire library, we've got this system that manages the updates separately while still giving us a unified view. It's like having a dedicated data librarian working behind the scenes, keeping everything organized and up to date. This feels incredibly efficient.
Exactly. And that efficiency is precisely why this technique is so valuable for software engineers. It allows us to build systems that can handle massive amounts of dynamic data without breaking a sweat. Now, let's get into the nuts and bolts of how this actually works in practice.
Okay.
The Snowflake Guide gives a really neat step-by-step example using a test harness scenario.
Yeah, love those.
Let's say we start with both the base and delta tables empty. As new data arrives, it's simply added to the delta table, like adding new books to that new arrival section we talked about.
Makes sense.
Okay. So far, so good. So we're basically just logging the updates as they come in.
Precisely. Now, when someone queries the view, like imagine searching for a book in our library analogy.
Okay.
The system intelligently uses the delta data to calculate the most current state. It's like the librarian knowing that even though a book is technically still in new arrivals, it's available to be checked out.
So no matter when you access the data, you're always getting the most up-to-date information.
Right.
But what happens when it's time to actually integrate those updates into the main library, so to speak?
That's where the automated job comes in. It merges the delta table data into the base table on a regular schedule, kind of like when the library staff finally shelves all those new books in their proper places. The source emphasizes that this job is independent of the incoming data flow, meaning new data coming into the delta table doesn't interrupt the merge process.
Ah, so there's this nice clean separation
Right.
between the ongoing updates
Yep.
and the periodic merging process. Keeps everything running smoothly.
Exactly. Now, there's a brief period during the merge where the same data exists in both the base and delta tables.
Okay.
But the view is smart enough to avoid double counting these rows, so you always have an accurate snapshot. Once the delta rows are integrated into the base table, the job purges them from the delta table, keeping things tidy and efficient.
It sounds like having a self-cleaning data warehouse.
Exactly.
And this whole process is streamlined even further by Snowflake streams, right?
Absolutely. Snowflake streams are a fantastic way to track and manage the delta table even more efficiently. They allow you to monitor changes as they happen, making the merge process incredibly smooth and minimizing the resources required. It's like having a system that automatically alerts the librarians when new books arrive so they can start processing them right away.
I love how this all works together seamlessly.
Right.
It takes a potentially complex problem, managing constantly changing data, and breaks it down into a system that's both efficient and elegant.
It's a beautiful example of how a little bit of clever engineering can make a world of difference. And it's not just theoretical. It's something that can be implemented and put to work right away, making our lives as software engineers a whole lot easier.
This whole system is like having a team of tireless data assistants working behind the scenes,
I know, right?
keeping things running smoothly. But I'm curious, are there other ways to tackle this challenge,
Oh, yeah, for sure.
of updating frequently changing data? Does the guide explore any alternative approaches?
It does, yeah. It's always good to have multiple tools in your toolbox, right? One alternative approach involves using timestamps as a sort of high watermark to keep track of which updates have already been incorporated.
Okay, timestamps. That sounds familiar. How does that work in the context of deferred merge?
Imagine adding a timestamp column to your base table, like a last updated stamp on each book in our library analogy. This timestamp would represent the most recent update reflected in the base table. The delta table, as always, would continue to collect incoming updates with their respective timestamps.
I see. So we're essentially marking the base table
Yeah,
with a timestamp,
right.
so we know it's already been accounted for.
Exactly. And when it's time to merge, we can use that timestamp in the base table to filter out any updates in the delta table that are older. We're basically saying, hey, we already have a more recent update for this record, so we can safely skip this one.
It's like having a librarian who can instantly tell if a new arrival is actually an outdated edition. This seems like a pretty efficient way to avoid unnecessary processing.
It can be, especially when dealing with data that arrives in chronological order. But there's a potential trade-off. Adding that timestamp column to the base table might not always be desirable, depending on your specific data structure and requirements.
So it's all about weighing
Right.
the pros and cons based on your specific situation.
Yeah, exactly. Like with any engineering decision. And that's why it's so valuable to have a deep understanding of these different approaches. The guide also discusses how to handle out-of-sequence data, which can be a real curveball in real-world scenarios.
Out of sequence data, that sounds like a recipe for headaches. How do you even begin to deal with that?
Well, imagine this. An update arrives with a timestamp that's actually older than the latest timestamp in your base table.
Oh, wow.
This can happen for various reasons. Network delays, data processing hiccups, you name it.
This is like a book delivery arriving out of order. The sequel shows up before the first book.
Exactly.
That could definitely mess things up if you're not careful.
The standard deferred merge approach assumes that incoming data is always chronologically ordered. But in the real world, that's not always a guarantee, so we need a way to gracefully handle those unexpected situations.
So how do we make sure those out-of-order books don't end up on the wrong shelf, so to speak?
The guide presents a modified approach to handle this. Instead of just comparing the incoming update's timestamp to the latest timestamp in the base table, we check if the update's timestamp is greater than or equal to the timestamp of the corresponding record in the base table. We're essentially ensuring that an update is only applied if it's genuinely newer than the existing data for that particular record.
Okay, that makes sense. It's like double-checking to make sure the book you're showing is actually a newer edition, even if it arrived out of order.
Precisely. And this way, even if updates arrive out of sequence, we can still incorporate them correctly, maintaining data accuracy without disrupting the overall system.
This is fantastic. I love how this guide not only presents the core deferred merge technique, but also takes us deeper into these nuances and alternative approaches, like a masterclass in efficient data management.
It really highlights the importance of thinking beyond the surface level. The real world rarely presents perfectly ordered data, so having strategies to handle these edge cases is essential for building robust and reliable systems.
Now, I'm also curious about those paths not taken. Were there any alternative approaches that the guide considered but ultimately didn't recommend?
Yes, there were a couple. The guide mentions using a full outer join to combine the base and delta tables.
That seems straightforward enough. What's the issue with that approach?
While it might seem like a logical way to merge the data, the guide points out that this method can negatively impact performance, especially when querying the data later on. Full outer joins can be computationally expensive and might hinder efficient data retrieval, leading to unnecessary delays and resource consumption. It's like trying to find a specific book by rearranging the entire library every time. Not very efficient.
Ah, so we might gain simplicity in the merging process, but sacrifice efficiency down the line. What about the other approach they considered?
The other method involves using a union all operation within a window function to combine the data. This approach also raised concerns about efficiency and the ability to filter data effectively.
So it seems like these alternative approaches, while seemingly simple, might introduce limitations that could impact performance and scalability in the long run.
Exactly. The guide's recommendation to stick with the union all with not exists approach, especially when paired with snowflake streams, seems to be the most robust and efficient solution overall. It provides a balance of simplicity, performance, and the ability to handle those tricky real-world scenarios we discussed earlier.
Okay, we've covered a lot of ground here. Let's take a moment to connect all of this back to our listeners. The software engineers out there building systems that need to handle constantly changing data. What's the key takeaway from this deep dive into deferred merge?
I think the main takeaway is this. If you're dealing with frequently updating data, deferred merge is like having a dedicated team of software engineers working behind the scenes to ensure everything stays organized and efficient. It's a technique that offers elegance and performance, allowing you to manage updates seamlessly without sacrificing speed or reliability. It's like having a system that automatically optimizes your data management workflow, freeing you up to focus on the bigger picture.
That's a fantastic analogy.
Yeah.
It's like having a self-managing data warehouse
Right?
that takes care of all the heavy lifting so you can focus on building amazing applications.
Exactly. It really is. And as software engineers, we're always looking for those elegant solutions, right?
Oh, yeah.
That make our lives easier and our systems more robust.
Right.
Deferred merge is a perfect example of that.
Yeah. It's like giving yourself the gift of time.
Mm.
And like mental bandwidth, freeing you up from those tedious data management tasks so you can focus on building the next great feature
Exactly.
or application.
And what's even more exciting is that these core principles of deferred merge, separating stable data from volatile updates, using a view to present a unified picture and periodically merging those changes, these ideas can be incredibly powerful across a wide range of applications.
That's what I was just thinking. We've been talking about tables and databases, but this feels like a much broader concept. Like, could you adapt this approach to manage other types of dynamic data in your workflow?
Absolutely. It's all about recognizing those patterns of change and applying these principles to streamline your processes. Imagine using a similar approach to manage user profiles, where the base table holds the core information and a delta table tracks updates like changes to preferences.
Right.
Or activity logs.
That's a fantastic example. You could even apply these ideas to managing configurations,
Oh, yeah.
game states,
Uh-huh.
or any system where you have a mix of stable and rapidly changing data.
Yeah, for sure.
It's about stepping back and seeing the bigger picture, recognizing those common patterns of data flow, and then designing systems that handle those changes gracefully.
Exactly. And that's what's so exciting about being a software engineer. We have the power to take these proven patterns, these elegant solutions, and adapt them to fit our unique needs, constantly pushing the boundaries of what's possible.
It's about thinking beyond the immediate problem, recognizing the underlying principles, and then applying those insights to create truly innovative solutions.
Beautifully said. And who knows what creative applications our listeners will discover. It's a challenge to all of us to take these ideas and run with them, experiment, and to share those discoveries with the community.
That's a fantastic challenge. So to all our listeners out there, we encourage you to explore the possibilities of deferred merge and similar techniques. Don't be afraid to experiment, to push the boundaries, and to share your insights. You might just uncover the next breakthrough in efficient data management. And with that, we'll wrap up this deep dive. We hope you found it insightful, and as always, we invite you back for our next adventure into the fascinating world of technology.
Until then, happy coding, everyone.